Hi everyone. Today we're going to go over lesson 3-1, and it's a lot of review from Algebra 1. So please write down at least this first slide so you have this for reference. We're first going to talk about the distributive property. You did this in pre-algebra and algebra. You guys know when you're distributing, you get A times B plus A times C. Now, this one is probably new. They don't talk about it a lot in algebra class. It's called the reflexive property, and it's when something equals itself. So if you have variables, it could be A equals A. If it was a segment, it could be segment AB is equal or congruent to segment AB. It could be an angle. Angle ABC is congruent or equal to segment ABC. I often call this the copy and paste property. And this is unofficial though. I mean, don't put that on your homework, but think of it as copy and paste. It has to be the same on the left as it is on the right. So a common mistake is like 1 plus 2 equals 3. I mean, that's a true statement, but is it copied and pasted? Is it exactly the same? And of course it's not. So that would not be an example of the reflexive property. I could have, though, 5 equals 5 because that is the same on the left and on the right. Now, the only time that this varies at all is like when you name angles or you name a side. I mean, when you name an angle, technically you can call this ABC or CBA. I always write it exactly the same so there's no confusion, but technically, if you wrote this backwards, because I mean, the rule is the middle letter has to be the same and the A and the C could be interchanged. Technically, that's also the reflexive property. I typically don't ever write it that way, at least not on purpose. Okay, so moving on, substitution property. You did this a million times in Algebra 1. So A can be substituted for B. So, you did this in algebra. Let me show you a quick example. You have this, and they say, hey, but, X is really 2. So you would substitute it in. You say 2 times 2 plus Y equals 10. So what you just did there is the substitution property. Now, as you solve it, you're going to use other properties. So we're not going to get to that just yet. So the addition property, you guys remember, you do it to the left, you got to do it to the right. So if you add on the left, you have to add on the right. Easy. Subtraction property, same thing. Whatever you start with, if you subtract on the left, you subtract on the right. That's the subtraction property. Again, with the multiplication property, you start with thing like A equals B. You can multiply on the left, you can multiply on the right. The moral of the story is you do it to one side, you got to do it to the other. And finally, the division property. If you divide on one side, you can divide on the other. Now, what's going to happen though is they're going to give you some algebra problems, kind of like the one that's up here. And you're going to have to justify every step. So if I had to justify this, let's change colors. Like from step 1 to step 2, what did I do? I did the substitution property. Now, on a side note, I want you guys to realize substitution and subtraction, every year, everyone wants to abbreviate it sub. And I think you can see the issue here. Sub is the abbreviation for substitution and for subtraction. So when you're doing your online assignment, please just write out the word or its multiple choice. Just don't write sub because I don't know which one that you're referring to. Okay, so the next step, technically, here, let me just write it like this. Technically, that would be simplification. Okay. The next step would be you would subtract the 4, right? So what are you doing to both sides? You are subtracting. So y equals 6, and that is the subtraction. Notice I didn't write sub property, and this is also a property. So notice I put at least the next 2 letters so you know it's substitution and you know it's subtraction. Okay, so this next part is much easier in person because we're just going to practice these. So if I go too fast, you can slow down the video in YouTube. So if I give you this, what property is it? You're doing something to both sides. It's the addition property. And again, if I'm going too fast, slow down the video. You go to the little wheel and you can either speed it up or slow it down. Okay, it's the same on the left and the right. That's the reflexive property. All right, so we're starting here and we're going to here. So what's different? Well, these are here now. So how did those get there? Well, you subtracted it on the left and you subtracted it on the right. So that is the subtraction property. So again, if is where you start and then is where you're going. So what did you have to do to get there? Well, we did that. And what's that called? The distributive property. Okay, so this one is a tricky version of something you guys know. So we have two ifs. We have this and this, but somehow it combines and you get this. So this is a tricky version of something we know. What did I do? I'm adding to the left and I'm adding to the right, which is addition, but they're different on both sides, right? I mean, the answer is addition property, but let's go back and talk about this. So I think everyone agrees 5 equals 5. And you start with A equals B. Okay, so if this is my if, and this is my then, actually, this is an and then what would be the outcome? Well, you could combine these together. A plus 5 equals B plus 5 because you're adding the same thing on the left and on the right. And that makes sense. Everyone says, okay, that's the addition property, no problem. But here's where everyone gets confused. If I change this to C equals D, I mean, it tells you C equals D. So technically, my then could be A plus C equals B plus C, because that's a D. I'm adding a value that is the same to the left and to the right. And so that's how they get this. So you have to just take it slow, look at the ifs. If you're combining them with addition, then it's the addition property. Ooh, I just gave you the answer. I scrolled too fast. Okay, so again, you're starting here, you're going here. How did you do this? Well, that's a division sign, so I'm dividing, division property. Okay, so look at all your ifs and then your then. How do you get there? All right, so what's different? I mean, that's why you need to start. Like the A's are the same, the B and C is the same, but the F somehow turns into a W. How does the F turn into a W? Can you take it out and replace it? So what's it called when you take it out and you replace it? The substitution property, of course. Okay, so this is not a property. We kind of talked about it earlier when I combined things together. So notice I'm adding on the right side, but are you adding on the left side? No, you're just combining them together. You're collecting them. So when I add it together, I get 180. So this is called simplification, or you could say simplify. You're just grouping like things together. Okay, so that's technically not a property, but we list it as one of the steps, okay? All right, again, you're starting here. How or what do you do to it to get to the conclusion? So your then is always your conclusion. So, your E's here, but how does the M move from the right side down here to the left side? Think of algebra. If you have E equals MC squared, how do you move the M? Well, You divide it away, right? And so after you divide it, you're left with E over M equals C squared. So what did you do to both sides? You divided. So that is the division property. Oop, just gave the answer. Bad about that. Okay, so again, you start here, you're going here. How does this get there? Right? You guys know it's multiplication. They're multiplied together, so it's the multiplication property. All right, try this one. I have two ifs. So somehow you're putting those together. How are they hooked together? So you're looking here. What does this mean? Is it addition, subtraction, multiplication, division? You're not substituting. This is multiplication, right? So this is another tricky version of the multiplication property. Again, if you have A equals B and 5 equals 5, you would have no problem saying, okay, my conclusion, my then statement could be 5A equals 5B, because you would multiply by 5 on both sides, because 5 is equal to 5. But down here, isn't C equal to D? So you can multiply by C on one side and multiply by D on the other. So there are two that are pretty tricky. Remember, it's the weird addition and the weird multiplication. Okay, so now we're going to do what we were kind of doing at the beginning, where you justify your steps. Okay, so I have to start you out with an equation. You're not going to make up the equation. So the thing that they give you, you're always going to say it's given. So there's different methods of doing this. You can number them. You can draw lines in between the steps. When you do one of these, you notice that there's this little T thing here. This is called a T chart. It's very organized. And, in algebra, you're always told, show work, show work, show work. Now you can show work, but it would be over here on the right or left side, like scrap work. Your steps is very clean, very fluid. You just tell me what's the next step. You don't have to show me what you're subtracting or adding or multiplying or dividing. So I'm going to do a little scrap work over here. So how do you solve this? Well, you're solving for x, so you're going to subtract 4. So what's left? And that's what goes into your step. So negative 3x equals 1. So then you're going to say, what property or what's the reasoning that I'm allowed to do this? Well, you subtracted. So remember, don't write sub. So you subtraction property. That is your reason. Now, technically, let's see. We need to go ahead and solve this all the way. So let's go back to our scrap. What would you do? Would you divide by negative 3 or would you divide by 1? Well, of course, if you're solving for x, you're going to divide by the number next to it. So my answer for the next step is x equals a negative 1/3, because what did you do? You did division. This is the division property. And you're finished. Okay, this is called algebraic proof. Okay, so on the next one, notice I'm kind of changing the words on us a little bit here. It says steps and reasons. And so I'm kind of changing it to statements. So statements is really the formal word of what we're doing. These are all statements. And you have your reasons. It's kind of like this is your if, and then you're going to justify it. So for step number 1, what do you write? It's always the same thing. Did you make this up or was it given to you? Well, of course it was given to you. Now, how would you solve this? And again, you don't have to show scrap work on the side. if you can do it in your head, this is the like one time math teachers say you don't have to show work. Of course, you're going to distribute. So you get 6x plus 27 equals 30, and that is what you're going to write here. Now, in the beginning, a lot of people get confused where to write the reason. So what you're going to do is you're going to come down, do the work, and go over and tell me the reason. So what did you just do? You did the distributive property. Good. Now, for step 3, you're just going to solve it. So you're going to subtract 27 to the other side. So 6x equals 3. So I went down, I showed my next step, and I go over and I say how or why I'm allowed to do this. So this is the subtraction property. All right, next step. What do you divide by? Do you divide by 6 or 3? And hopefully you're saying 6. So x equals 6 over 3. Or I'm sorry, 3 over 6. Said that backwards. Okay, so what property did you use? What did you do to the left and right side? And of course, that was division. Now, technically, remember, whenever you do something like this, that's not a property, but we have a word that we can use. We can say simplification or just simplify. And this is your final answer. Now, you don't have to circle it, though. All right, so this is a completed algebraic proof. Again, notice you always go straight down and over, straight down and over. A lot of times people forget this first step given. And so when they're done, they don't have anything here. So if that happens, you have to shift everything down and go back and put your given at the top. So remember, the first thing, you don't make it up. It's given to you. So you have to write given. Okay, so when you're doing geometric proofs, you're allowed to use any definition that we've talked about in class. And so that's why in some of the videos I've said, oh, you might want to document this definition like at the back of your theorem and postulate sheet. It might help you keep track of all your definitions. So you're also allowed to use any theorem that we've had, which that's when you would reference your theorem sheet again. You can use any postulates, and again, they're on your theorem and postulate sheet. Now, corollaries, those are kind of like a theorem or postulate. They're usually very basic things you could figure out on your own, but we document them so you can reference them and use them within your proofs. And again, those will be on your theorem sheet. We will fill those out every chapter. And finally, we can use our properties. So the idea of a proof is we're going to use everything that we've ever learned within this course to help justify it. So it's not like algebra where you just learn a topic and you do it that day and you move on. You have to remember everything that has been taught, which is very difficult. And that's why I allow you to use your reference sheet, which is your theorem and postulate sheet. Okay, now this looks scary. So let's attempt this. Now, when this is a very formal looking proof, notice the left side is called your statements and the right side is called your reasons. They're going to tell you what the goal is. So think of this as the goal. And down here, this is what we're going to prove. So this is your last goal. So this is what you're going to think of in the beginning, and your goal statement has to be, okay, what's the process to get me to the end, okay? So before we even start, if I give you blanks like this, you know this final proof statement will go here, okay? This is always the last step. Now, we have to get there, okay? So all of this information is your first step. And notice I already typed in, it was given to you. Now there's this other information here, and that comes straight from this graph right here. Now this little m means measure. It means the measurement of angle CAB is 7x plus 2, and the measure of DAB is 5 times the quantity x plus 4. Okay, So all of that is my given information. Now, we have to always look at these for clues. Now, my big clue here is a vocab word. So whenever you see a vocab word, you have to use that and apply it. Okay, so what does bisector mean? Bisector from chapter 1 means it takes the angle and cuts it straight down the middle. Now, the way we can show this on a diagram is draw a little arc with a slash through it, an arc with a slash through it. And as soon as you look at this picture, that indicates I know those two angles are the same measurement, even if I draw a picture that's not to scale. So I'm just going to, like, that obviously is not to scale. But if I put that marking on there, that indicates, even though my picture is not great, I want those to be congruent, the same measurement. And again, congruent means they're the exact same degree or measure. So how do I know this? What vocab word tells me that angle CAB, which angle CAB is this angle, is the same as BAD? How do I know that? Well, they gave us a big clue. They told us it's the bisector. So if I bisect this angle CAD, it forms these two smaller angles. So this is the definition of bisector. So again, if they give you a big blaring vocab word, know that you're going to apply that within your proof. It's usually the next step. Now, from step 2 to step 3, notice I'm going from names to values. So I can take the name out and replace it with its value. We talked about this last lesson. What's it called when you take it out and replace it? Is CAB the same thing as 7x plus 2? Of course it is. Is angle BAD really 5 times quantity x plus 4? Of course it is. So I'm going to take out the name, replace it with the value. So this is called the substitution property. And notice I didn't write sub. It's the substitution. So either write out the word or at least put the ST at the end. All right, so from step 3 to step 4, what's happening? Well, the left side stays the same, right? But the right side, you're doing an algebraic property. What's that called? D word. Distributive property, right? Now, you have 2 steps you have to do on your own, and these are algebraic proofs, kind of like at the previous example. This is where you're doing your work. And again, if you are a student where you have to show your work, you would come over here to the side and say, what's the next step? And this can differ from student to student because technically I have 4 choices of things to move. I always look at the variables and I move the smallest variable. So when I subtract or add, my variable stays positive. Because if you remember, if you move this over to the other side, the variable would then become negative, and I just don't want to deal with negatives. So this step will be now step 5. What did you do to both sides? Well, you subtracted the 5x, so this is the subtraction property. All right, let's go back over to our scrap work. What's next? I would subtract 2. So 2x equals 18. So I come over here to step 6 and say, okay, 2x equals 18. What did I do? I subtracted again. Now, my last step, I already know. Now, guys, never say proved. Oh, no, don't ever do that. Never say proved or finished or done because that just proves to me that you don't understand. You always go down and then over with your justification. Okay? So, how do you go from step 6 to step 7? You do not say done. You do not say finished. You would divide, right? So, this is the division property. You need to have a reason for every step. Okay, again, if you get to the end and you're off, maybe you forgot to say given at the beginning. So when you're finished, again, I can't say this enough, you will never have an empty blank for the last box. Okay. So I know this is a lot, ask questions. I'm happy to help you. Rewatch this if you need to. It does take a little bit of time. Okay. Again, very formal looking. This is a T-chart proof again. You have your given and you have your proof. Again, your proof statement always goes in the last box and it's already typed in here, so you don't have to write it in. You know you're not going to say finished or done here or proved. Now, how do I know this first step? Is it told to you? And it is, right? It's told to you right here. So this is the G word, given. Now, how do I know all this stuff? Well, sometimes they give you more than one given. Do you guys see it right here? It's given. So you're going to say given again. Now, it's not given, okay? So now you're going to say, how do I go from step 2 to step 3? Think of step 2 as your if, and step 3 is your then. What are you doing? Now, here's the situation. Here's angle 1. Here's angle 3. Now, for this honors textbook, he calls this substitution. I realize if you're working with a tutor, they might say it's a different property, but your textbook tells us to call this substitution. Okay? So, the way he justifies this is he says, does angle 1 equal 4? Yes. Does angle 3 equal 4? Yes. So can you take out angle 4 and replace it with what angle 4 is equal to? Sure you can. So let's take out angle 4 and replace it with what angle 4 is equal to. So angle 1 equals angle 3. So this is, go ahead and say it, what's the word? Substitution property. Do not write sub. Now, you cannot think of each step as an island, okay? They're stepping stones. You're not on an island by yourself. It's a stepping stone. How do you go from 3 to 4? This is your if. This is your then. What's happening? Now, here's angle 1. Perfect. But these aren't the same. But what do we know about those? What's angle 3 and 120's relationship with each other? Look at step 1. Are they equal to each other? Yeah. So can I take out angle 3 and replace it with what angle 3 is equal to? I sure can. So that is called, let's take out and replace called the substitution property. You got it. All right. So if you have questions on this, please ask. I'm very happy to help you. Just reach out. All right. So the problems I've covered so far, those are very much like normal core 40 geometry. Now, your textbook tries to help you, but sometimes it makes it more confusing. And I'm going to show you what I mean by this. He gives us no picture. He also, when I say he, I mean the author of your book. He doesn't start you with a given, which is irritating. Okay, so let's go through this. Again, this is how your book does it, and your book requires lots of higher order thinking outside the box, which sometimes equals frustration. So that's why I offer you guys to message me anytime. And also, when you guys message me, please send me a picture of the question because I don't always have like my Canvas open. I might be out doing something with my kids, and I just need to see the picture quick so I can respond to you quickly. Otherwise, you have to wait till I go home and look it up and then answer you. All right, back to this question. you have a triangle. Angle C is 90 degrees. And if pictures help you, then, draw it out. You have a triangle. Angle C is 90. And angle B is twice as large as angle A, which my picture is not to scale, obviously. But there's at least a diagram. Now, I told you usually it's a given, and usually it is. But sometimes you just have to look. This is not given. How do you know 3 angles add up to give you 180? This is something that's on your theorem sheet. So go and look at it. It's from chapter 1. When you add everything together, equals 180. The long name. This is the triangle angle sum theorem. If you don't remember this, go back and look at your notes and find it. And all it says is when you have a triangle, all the angles add up to give you 180. Now, here's where your textbook is trying to help you. It's saying if you have this, it's reminding you it's a given. How do you get this next step? So how am I going from step 1 to step 2 using this if information? Okay, so if you like numbers, we can number this 1, number this 2. What I have circled here, this is just a reminder. Hey, use this. So if you're doing this problem totally confused, just go slow. It's angle A, angle A, angle B, 180, 180. Oh, these two change. What do you know about that relationship? Well, look over here at this big reminder. Isn't angle C the same thing as 90? Sure. So can I take out angle C and replace it with 90? Sure. So when you take it out and replace it, this is your substitution property. All right, so that's how that all works. I don't know why you erased the numbers. So let's look at step 3. Again, he's trying to help you. You say, hey, look at that. And how do you get this? Okay, so technically, this first part that I have boxed is step number 2. So how do you get to step 3? So again, go slow. Here's angle A, here's angle B, but the 90 is gone and the 180 turns into 90. So what do you have to do to make that happen? Don't you just subtract 90 to the other side? Sure. So this is called what property? The subtraction property. Of course. Okay, so again, they're saying here's this, so we're going to use this information again. And they're telling you this. How do you know this? And they're just reminding you that it is a given. So if you look way at the top, angle B is twice as large as angle A. So that's where they get that. So if you're going to use these 2 pieces of information, let me erase this. How do you get this? Again, the moral of the story is go slow. Angle A, 90, 90. What do you know about these 2? Are they equal to each other? Sure. Can you take one out and replace it with the other? Sure. So we're going to call this, again, substitution property. And yes, we use substitution very, very often. Now, step 5. Come on, pen. Now, how did he get this? Now, if you were writing a proof on your own, I would say you would need to show a step. When you combine these, you're simplifying. Your textbook makes me crazy. He doesn't show that. If it was a step on its own, yes, you would say it's simplification or simplify. Again, that's not a property. Do not say simplify property. Back to number 5. How do you get this? How does this little 3 go away? So this 3 is the issue. How does it go away? Well, you would divide by 3 on the left, divide by 3 on the right to get the 30. So this is your division property. Whew. So again, this is a lot. There's tutorials every day during third period. You can message me questions. I'm happy to help you. Do not struggle at home in silence when there's, me to help you. All right, so normally we do 2 lessons in one day, and we're only going to do one. So you can go ahead and stop the video. I'm going to go ahead and do the video for the next part. Okay, the ruler and distance. Postulate 3. So this is on your theorem and postulate sheet. And what it is telling you, the ruler postulate just allows you to find measurements. Okay, so if you have a number line, how do you justify that you're finding the measurement? And you would say postulate 3 or the ruler postulate. This is a weird case where he gave it a name, the ruler postulate, and he gave it a number. So technically you can refer to it as either. Most of your assignments, I just put the postulate number, like postulate 1, postulate 2, postulate 3. So whenever you're finding a length, a distance, all you have to do is subtract the coordinates. And distance has to be positive because if you think about it, like here to Florida, it's a positive difference. You would not say it's negative miles away. And there's always the kid that says, if you drive backwards, guys, if you drive backwards, it's still a positive difference. You just look silly in your car. So technically, what we can do is we can take the 4 and subtract the 7. And this is where people goof up because they say the answer is -3. But you have to think it has to be positive. So you have to take the absolute value of it to get 3. Now, a way around this is just start with the bigger number. Let's start with the 7. So always start with the bigger number to get a positive answer. So from B to C, which, I know you guys can just count. If they were bigger, we can change this and say, let's go and let's put coordinate Z down here and make it -1. Okay, and so if I have, what is the length of ZC? Okay, so you have -1 and +9. So that's a little bit more difficult. How do you do that? And I realize there's a bunch of coordinates in here that I didn't draw. What's the rule? You subtract. So -1 minus 9, which is -10. But you guys know it can't be negative, so the answer is +10. Now let's say you want to do the coordinates opposite. Remember, always start with the bigger coordinate. So 9 minus the -1, and double negative turns into a positive, so your answer is 10. Now, this is a new notation down here that we need to know, and I know it's on a quiz or test or something coming up, so know this notation. You don't just say A, B, C. The way you read this is really weird. You say B is between A and C. Now, it doesn't mean it's in the middle, like the midpoint. It just means, hey, it's hanging out in between, right? So the way you would write this out is B is between A and C. When I say B, I mean point B. When I say A and C, I mean those are points, point A and point C. Okay? Now, we call this the betweenness of points theorem. If you have a tutor, they're probably going to call this segment addition postulate. We don't call it that in this class. We call it theorem 1, betweenness of points. And yes, betweenness is a real word. Who knew? Okay, so if a point is between two other points on the same line, then its coordinates is between its coordinates. So here's what it means. You have a segment. Actually, there's multiple segments here. What's going to happen is if I add AB together, and then I add up BC together, it forms a bigger segment called AC. So I always call this little segment plus little segment equals big segment. Okay? If you can remember this, it's like Legos. You have a little Lego and you connect it to a bigger Lego, then it makes a much bigger Lego, right? Or a fence. You build a little fence, then you build a bigger fence, and all of a sudden you have this much longer fence. Little plus little equals big. Now, this notation is telling you B is between A and C. It's not the midpoint. So that means these segments are not necessarily equal. But if you're adding a little segment and you add a little segment, it makes a bigger segment. Now notice they both have a B in common. So what letters are left? A and C, which is right here, A and C. So if I have XY plus YZ, what should it equal? Little segment plus little segment. Remember, the Y's, are the same. So what's left? Y, Z. Little plus little equals big. Okay, so suppose M is between L and N. And they tell you L to N is 23. How do you find, now, what this means is find the measurement of LM and MN. I don't want the little, expression. I want to know the actual number. So what we're going to do is little segment plus little segment equals big segment. So what is the value of this first segment, which is 3x plus 8? And what's the value of the next segment, which is 2x minus 5? And what's the value of the big segment? And that is 23. So little plus little equals the big. Okay, so this is your equation. Now we're going to solve it. Now remember, you have to combine like terms. Group them together. You're not subtracting and adding like to the opposite side yet. So 3x and 2x is 5x. 8 and a negative 5 is 3. And then I'm solving. I'm subtracting 3. So 5x equals 20. And then I'm dividing by 5. So x is 4. Now, if you read the directions, it doesn't say what's x. So in geometry, you always solve for x, and then you reread the question to see if you have to plug it back in. And it says, what's LM? Okay, so LM is 3x plus 8. So I need to do 3 times 4 plus 8. And x, remember we just found x, I replaced it. So 12 plus 8 is 20. Okay, so let's find mn. And the equation is 2x minus 5. And so I know x is 4. So 8 minus 5 is 3. Now, this makes sense because if I add these two numbers up, don't I get the total of the 23? Sure. So we are finished. Again, this is called betweenness of points, and we are finished. So you can ignore this. You're going to do the assignment that's posted on Canvas. And again, please don't struggle. Ask questions. I'm here to help and support you guys. Thanks. Bye-bye.